I have a big challenge. I have only 40 minutes. I have an agenda that includes a demo and a new technology that you may or may not have heard. But it's really all about the simplicity that Kevin mentioned. It's about embracing the source routing paradigm of segment routing. And how does it help, maybe for the first time in 20 plus years, to bring traffic engineering to the masses? Bring it with simplification, bring it with scale. We did it, and we think with the new member of the solution called segment routing flexible algorithms, we're going to take it even up one notch to the next level, even more to the masses. So we're going to talk about segment routing flexible algorithms today. I'm going to assume that the audience here in the room and in the web has a basic level of familiarity with segment routing, so I'm going to go straight to my points. There are many resources where you can actually catch up if you haven't. So we're going to talk about the overview, how it operates, and that's the techie, boring stuff. What I want to get you excited is on the use cases. But I got to cover that first, then we go into the use cases, and then this is not PowerPoint, this is real. We're going to see a live demo. All in 40 minutes, maybe 35 by now. So why are we here? So we're here to actually obtain a very plausible goal, which is, have you ever imagined that you can tell ISIS, OSPF to compute a path according to your traffic engineering needs? Give me a path that goes to John avoiding Kevin. And this is all computed by the IGP. Give me a path that goes to Kevin, minimizing the delay from me to Kevin. Not only the IGP metric, I want to minimize the delay. And I'm not talking about the T metric. I'm talking about the real delay on the links between me and Kevin. Can I have a path to John that only uses encrypted links? So now I have enabled MACsec. I want to have a secure path. Can I do that? Now, extremely important point. Can I have that path to Kevin using only MACsec links? And if I enable fast read route with TILFA, can the backup link be guaranteed always to stay in MACsec links? That's the power of the semantics we're talking about with flexible algorithm. And we can do it based on source routing. We can do it based on the simplification and the scalability elements that segment routing has in general. I hope these reasons will keep you excited for the remaining of the time. I'm very excited, as you can tell. So the overview. We call it Flex Algo because you decide what it will do for you. You go to our router and you tell it, I want you to compute based on delay. I want you to compute based on IGP and minimizing or excluding some links in the network. You tell it, the router, what to do. That's why we call it Flex Algo. We talk about a Flex Algo instance. We put a letter to it, Flex Algo K. So for you, you could say that the metric of the Flex Algo may be the delay, maybe the IGP. You could add constraints to the Flex Algo definition K, and you could say, I want to avoid or include certain links of affinity colors. So as an example here, you see a topology that has 8 routers. And you could say, I want to have a network slice, very common buzzwords these days, that only includes routers in the bottom half of my topology. And I want to be able to reach any destination on that slice, avoiding the brown links and minimizing the IGP cost. So my path from 6 to 4 will follow the blue arrow in the picture while staying only in my red slice. I have one IGP process. I have one ISIS instance that runs across these 8 routers, but I can further carve out my network slice. I can also come in and say, I want to have another Flex Algo instance, 129, where I can say, I want to reach any destination in that Flex Algo, minimizing the delay to the destinations. And now I give you a hint of the delay on the links, delay 10, default delay 1. I go over a different path to the destination.
So how granular are we talking here? Because you've described multiple Flex Algo to give you different slices. Can that go down as granularly as per flow, or?
Well, so So the question is, once I define this slice, how do I put traffic into the slice?
Yeah.
And you have options to do either per destination steering, where some traffic to a destination, all flows go over a slice, or you could say flows are intended to go over a slice. This is how we decide into the next topic, which is the steering of traffic into the slice. We'll cover steering coming up.
You have an ability to stack these on top of each other. So if I want to have a minimal delay plus max sec, I don't need to create a policy that is those two, but I can mix them together.
Well, in fact, I'll show you examples in the use cases where I do delay and max sec or delay alone. The other thing is that these slices, as you see here, they're actually overlapping each other. So I have the same routers which are doing participation in two slices. But here's the million-dollar question. How many labels? We're doing source routing, right? So we're doing segment routing. People think label stack. How many labels do I need to push on 6 to get to 4 and have the objectives of the slice in the left? And how many labels do I need to push on 6 to get to 4 for the objective of the other slice? Does anybody has any clue of how many labels do I need to push at 6? Just guess. Think simple.
3.
3? Right? Anything else? Think 1. Because I have a path that the IGP computed. We're going to talk about that later. How is that done? I'm achieving a source routing policy based on the semantics of very complex I just described. I am pushing 1 label. So when I think Kevin had a question for our Kevin, or no, Kevin, yes. Kevin to Kevin, about Cisco strategy. What are you building to deal with the new world and cost-optimized platforms? Well, we got to be careful how many labels I need to push on that box, because it might not be able to push as much as a box with a custom ASIC. And that's important.
Does that mean you guys are using commodity ASICs on some of the newer gear, or is that in the mix? I mean, I know Cisco has always been known for custom ASICs for years and years and years, and I know that you started experimenting with commodity ASICs, and that's part of the next generation of the architecture?
No, it's already shipping. The platforms that Kevin alluded are actually using merchant silicon.
And that's like the NCS?
Yeah, the NCS 5500.
Okay, because I've got a project doing it with an NCS 5500 right now, and I haven't touched it yet, so that's interesting to me.
Merchant silicon, yeah.
Okay, cool.
Indeed. Operation. What happens now, I'm going to use a picture of a use case. This is the multi-plane core use case. You see routers on the top that have a green color, routers that have a red color in the bottom. You have routers that have a gray color. The convention is in the left. The routers in gray, 0 and 9, participate across all Flex Algo instances. Algo 0, Algo 128, Algo 129. The routers in green participate in Algo 0 and Algo 128. And the same for the routers in red. By the way, Algo 0 is what everybody knows about segment routing. When you enable segment routing, you are doing Algo 0. Meaning, take me to Kevin by minimizing the IGP cost. That's really what Algo 0 does. Flex Algo follows your orders, not only the default order, which is follow the IGP. So here's the notion of the membership. Now, this is the important part. Now you grab a router like Node 9 with a loopback, a single IPv4 loopback, and you can now configure multiple labels for that loopback. These are multiple identities. Router 9, 1.1.1.9 has a label to follow the IGP, or a label to follow Flex Algo 128 instructions, or a label to follow Algo 129. That's key. Back to simplicity. We're not forcing our customers to configure a ton of IP prefixes to achieve this. One loopback can host multiple labels, multiple identities. So in this case, I have an example of 1.1.19/32 with the labels I mentioned in the previous case. You will see them in action.
So rather than iterating loopbacks for TE paths and things like that, you're able to consolidate that all and just rely on a single loopback for a device.
Single loopback. Then, depending, well, we are going to talk about intent-based networking. Based on the intent of the service, or back to your point, the intent of the flow, I can push the label for that destination that gives me the underlay SLA that I wish. Okay, so we're still in the techie side. The operation. First, I need to be able to define membership into a FlexAlgo instance. So if we take the topology on the top, I have two FlexAlgos, P and Q, and then I'm going to look from the perspective of node N, and I'm going to say, I'm N, and I belong in FlexAlgo instance K. You got to tell me that. But it is as simple as it sounds, membership. Then I need to have a definition of FlexAlgo K. We all have to agree that FlexAlgo K will minimize delay and avoid brown links, or it will minimize IGP. So that's the definition of FlexAlgo K. I am node N. I need to have a definition of FlexAlgo K. It can be locally configured. It can be flooded in the IGP. Now it's my turn to do something. I'm node N. And what I'm going to do is I'm going to arrive at the topology of FlexAlgo K. We call it Topo K. Topo K will prune any node that is not in K. It will prune any link which is excluded from the definition of the algorithm. And then my resulting topology is Topo K. Now here is the moment of truth now. I have a subtopology. I now run shortest path to destinations on that FlexAlgo in using Topo K only topology.
And this is all computed from the ingress router, from the router that is nearest to the traffic that you're looking at?
No, every router in the FlexAlgo instance is running ISIS or OSPF. Mm-hmm. Everybody is computing their IGP shortest path to other prefixes in the same FlexAlgo.
But as far as the policy definition, the policy definition happens on the ingress router, and then the computation is coming in from the IGP that's building these paths. So does the policy have to exist on every router or only on the ingress router?
Well, actually, what you will see, this is actually all IP stateless, so there is no policy definition on the midpoint, only on the router next to the source. Okay. But I wanted to actually further expand what you said. The policy definition may never need to be there. It could be on demand. So let's say you, Kevin, send a route to John where you express intent. John may have no policy configured, but the arrival of the route with the intent will cause John to create a policy on demand, and you will see that. But in general terms, there has to be a policy at the head end, no state in the middle. The policy at the head end can be triggered on demand. It can also be locally configured. It can come from a controller. Gotcha. Multiple ways to get the policy at the head end.
So you're using segment routing.
In this entire presentation, I'm relying on segment routing principles, yes. Absolutely. Then I know my shortest path to the destinations. Then I program my fib. Remember how one loopback has multiple labels? I program my fib entries for those labels. This is an absolute, extremely important point. And I said it already before. I have TI-LFA, segment routing, 50 millisecond protection, any topology guaranteed. Not only my primary path obeys the definition of the algorithm, my backup paths obey the definition of the algorithm. And that's the point that we make here. Many of our operators who actually led us to resurrect this concept are ones that have very stringent requirements where they say, I cannot afford 20, 30, 40 milliseconds of traffic over a backup path that goes outside of my desired slice. It needs to be on the slice all the time, guaranteed. And that's the point that we make here. This concept, and this is how it's so beautiful, it doesn't really apply to just ISIS. It is an IGP concept, ISIS, OSPF. This concept, you will see it today in the SR MPLS world, but it's also applicable to SRv6 as we move forward. This concept is not proprietary. Here you see a number of drafts that pertain to the solution. The third draft on the list is the draft that was created to advertise the customization of the algos. Everything else, the ability to have an algorithm to a prefix seed was already thought 3 years ago. I gotta say, that was genius. Already had the concept, the TLVs in the IGP already had the provision for an algo. What we introduced in the last 18 months is the flooding of an algo definition. That is the third draft. Everything is standardized. So that was the techie part. I think the next part is the more fun because we get to know, how do I eat this thing? Is this of any use? The use cases. We covered this picture in my multiplane, but it is a goal of every architect to be able, assuming I have deep pockets or I buy cheap enough gear, to be able to build resiliency on my core or on my WAN and even have the ability to have multiplane networks that are real. You see, everything we're talking here, we're not doing multi-topology routing. We're doing a much simpler solution that is at the hands of every operator and every piece of hardware without the complexity of multi-topology routing. I have my 2 planes. I have my loopback 9 with the 3 flex algos. And you can imagine that algo 0 means take me across any plane. Algo 128, take me over the green plane and minimize IGP. Algo red, take me over the red plane and minimize delay. That's really the intent that you told me as a router to do. And if you remember the labels on the far right, hopefully that's not too tricky. What would happen if node 0, back to your question about the policy head end, what would happen if node 0 imposes the label 16,009? Back to your question about segment routing. 16,009 is the label of algo 0 of 9. If that head end pushes that label, the traffic will follow all ECMPs across all planes. This is your algo 0. Okay? This is what we know.
Which is why you said that the routers on the other side don't have to have that policy enabled until that.
Oh, absolutely not. So the actual imposition happens on 0. The routers 1, 4, 2, 3, they're just doing label switching on that label. There is no state, back to Kevin's point. Okay. So far, this is pure source routing. What is new now is, from what I have explained to you, what happens if somebody, or if node 0, pushes the label 16,809. This is the algo 128 seed of 1.1.9. The packet will ECMP, but only go over the red plane, the green plane. The network will take care of this. It's already programmed that way. If I push now you will know the answer. What happens if I push the label 16909, which is the red plane seed of the destination? You go over the red plane. One label achieve the whole multi-plane use case. Now, nobody makes money computing IGP paths for traffic engineering. We make money selling services. So back to the question of flows, how do I put service routes onto these flex algos? And how do I do that? Back to Kevin's point, how do I do that even without having to touch the source? I don't want to create the policy. I want the policy to come online. And that's the concept of automated steering. It's not a new concept for Cisco in segment routing traffic engineering. It's a very interesting concept that now gets reused with FlexAlgo. And here's the semantics. The router in the source will have a template. It's a recipe. The recipe will tell me, if you see intent expressed on a color semantics, like a color 100, it's a BGP community that I put onto my service routes. If I see the intent of color 100, I want to have a path that stays in the FlexAlgo 128. That's it. Now, but a path to whom? If I receive a BGP route from John with the intent of 100, I need to push a label for John's loopback on this SID, on this algo. Remember that the loopback had 3 labels? Well, here, I know which one I have to push. And then I go to John over the red plane, over the green plane. That's automated steering. Back to your question about per flow or per destination. Here, I'm achieving per destination steering towards prefixes advertised behind John. If you come with us to Cisco Live Barcelona in 2 weeks, we're going to announce the first time the per flow automated steering, where now Kevin can send me a route with an intent for per flow steering. So flows to one destination can follow one slice, flows to the same destination can follow another slice. We call that per flow automated steering.
And that's like that can be all the way down to the subscriber level, like even in the last mile, you can get that granular.
It depends to the granularity.
Or is it at the aggregation network?
No, it depends to the granularity of your access device or whatever is next to the user to identify flows.
Okay.
Whatever is his granularity based on the hardware, then we don't care.
So if you don't have a BGP network, let's say you have a BGP-free section of the core. I know you mentioned BGP communities as a way to trigger that on-demand policy. Are there other ways to trigger that policy if you have a segment that's not BGP-enabled?
Well, actually, we don't really care that the underlay be BGP-free. Actually, most likely it's going to be BGP-free. But the actual revenue-generating services, like your VPNs, are BGP.
Okay.
So the trigger to these on-demand policies are BGP service routes.
Gotcha.
EVPN, so Giri will talk about EVPN. It could be L3 VPN. It could be global BGP prefixes. So now, if you look at my example of the multiplane, and you look at the template I showed you before, and now I have a flex algo, if I receive a route for prefix 8/8, it's a VPN route. Okay? I have a VPN label of 80,000. The route is coming with a color 100, which is my intent. I have my recipe of intent on node 0. This recipe of intent was configured at the very beginning of operation, day 0. I color my route 8/8. It arrives from BGP perspective from my route reflector, and then I program that route to impose the label of the BGP next hop, which is 9, using the seed algorithm of 8, that's 16809. If you look now at the fib entry, this is abstracted a little bit. You see how traffic that needs to go to 8/8, we're going to push 2 labels, the VPN label and the flex algo seed label of the next hop. And that will guarantee that you are on your way to go to 9 over the green plane. Imagine the power. You can have one VPN where some prefixes get this hint, others don't. I am enforcing this on a per prefix basis. I could do it on a per flow basis from what you're going to hear from us in 2 weeks.
So one use case of this could be I'm peering into an IX, and I've got Netflix is in this IX, and other content delivery providers are in this IX, and I want to steer traffic towards Netflix or those providers, and I can do that on a per flow basis with this to steer to that peering point, whereas I can take other traffic that I want, and on a per flow basis, send it to other peerings. And that would maybe one, that's one that I see that you're using this for, that you would use traditional TE.
Well, you could definitely aim the same goals here, and even more without having to configure any policy on the head end, and just let the intent drive it. Obviously now, if I receive a route like 7/8 with no color, there is no color on the slide, then that traffic will get pushed the Algo 0 seed of 9, and then you can go over any plane. This is when we start talking about 5G and mobile, and in general terms, people who are more worried about the delay of the path. You can now, if you look at this slide here on the upper right-hand side, the numbers you see on the slide are the measured delay of the links across the topology.
So that's real time. That's That's a real time value instead of just setting a bandwidth attribute in TE.
Or even a T metric. This is a measure per link value. You could now tell ISIS in this topology, I want you to compute to minimize the delay from me to anybody else on that Flex Algo instance. And if you assume that the ISIS IGP metric is the same, what you see on the bottom in blue is the ECMP path to go from 0 to 9. I have 2 paths ECMP. What you see in green is the computed path from 0 to 9, minimizing the delay. And you can have a flex algo instance doing this path on the right-hand side, and the regular IGP computation doing the default computation. And again, you push one label to be on the blue path or one label to be on the green path. So this is a very commonly requested use case. The other one I mentioned is, what about if my network is, I'm security conscious, or I have to enforce policy by governments that traffic cannot leave a particular country or a particular region of the country? There are regulations now that require that. Well, we can actually also compute a flex algo. In this case, we're using MACsec as an example. The colors of the links in the picture reflect whether they are encrypted or not. So I think if I use brown for unencrypted, I use green for encrypted. I could have a flex algo in the right-hand side where I can say exclude any unencrypted links. So my only links remaining in my top OK, if you remember, are MACsec links. So what you see on the lower right-hand side is a path from 0 to 9 that only followed MACsec links.
And you said you could stack these. So if I actually wanted to do enforcement on MACsec, and then I also, within that, once we get only MACsec links, now I want to compute
On delay.
on delay, and how deep can you go with that?
Well, so actually, we have to look at the flex algo definition. There are two concepts. One is the metric type of the flex algo, and then the other one is the constraints. So metric is one, so I do metric delay, and then constraints could be exclude unencrypted or include encrypted. So these are two different variables that you can put together and to define what the flex algo K means.
Gotcha.
Okay? What you see on the screen is actually a GUI that speaks to a segment routing PCE. It's a network function that computes path, but also collects topology. And the topology that was collected by the segment routing path computation element is being displayed in this UI. The topology includes the same routers that you saw in my slides. And what I wanted to start is by showing you the layout of the topology with the IGP costs. All the IGP metrics on the links is 10, but if you see the horizontal lines have a high IGP metric, maybe they're more expensive. Maybe I don't want traffic to go over there. Back to the question, I think, from Kevin. If I now switch my metric view to latency, what you see here is the actual measured latency of all of these links at this very moment on the topology. These are all back-to-backs. They're not going across the nation, so they're very low microsecond value numbers. So this is my view of the delay metric on the links. Why don't we take a look at the flex algo definitions? I have 4 flex algos in here. I'm just going to preview 2 of them. If I pick Algo 128, look at my subtopology. Now, my entire topology became this. This is what I want to use when I have policies across the network. Okay? I don't want to go over any of the other routers that are not there. And here, I minimize my IGP metric. Let me show you another algo, Algo 129. In this algo, I don't want to be on the top. I want to be in the bottom. So this is what we did. We defined the membership, we defined the definition, and then here you see a view of what that slice looks like. Okay. I'm going to come back to all the routers, and I'm going to come back to the T metric, to the IGP metric. And now I'm going to come back. In this case, Kevin, I have locally configured policies at the head ends. I have policies on 4. I have policies on 5. I'm going to only show you policies that are on 5. I call them foo. So let's take a look at a policy that is foo IGP. Foo IGP is a policy that goes from 5 to 4 across anywhere, minimizing the IGP metric. So based on the link metrics you see there, I have a cumulative metric of 40 to get to 4, and I go to 8, then I do ECMP between 1 and 7, come back to 3, and then to 4. This is my path if I go across the entire topology. This is your Algo 0 path. You can see in the bottom, actually, if I scroll down, you can see the label that I use on that policy, 16,004. That's my Algo 0 seed. Let's come back to the two more policies. I want to show you a policy foo that is staying in the Flex Algo 128, that upper half picture. Look at what happened. Traffic comes from 5, goes to 8. I don't go to the bottom anymore. 7 is not in my slice. Go to 8, go to 1, and then I continue on that right-hand side. So node 7 is not there because that's how I define my Flex Algo. And if you look at the bottom, the label that I'm pushing is 18,000. My Flex Algo label for that BGP next hop. If I overlay that with the actual slice, you can see why that happened. This is my slice on Flex Algo 128. I don't go outside of it. Show you one more policy, and we'll be done. Let's come back and show all the routers. Let's come back to the delay. And I'm going to show you one last policy, which is the policy foo on Flex Algo 130. This one minimizes the delay. You can see, if you remember from the previous, the path is not the same. I go to 1, and then from 1 I do ECMP to 2 and 3, and then I go to 4. Why do I do that? Take a look at the delay figures. Go to 7, go to 6, go to 2. This is my shortest delay path between 5 and 4. Completely different from the path on IGP metric. Computed by ISIS, and to enforce it, I push the label 20,004, which is my Flex Algo 130 of the BGP next hop 1.1.4. And that's really the live demo for Flex Algo running ISIS in this case on a topology using real routers and then being displayed on this UI through a segment routing PCE. Any questions on the demo before we go to conclusions?
How do you troubleshoot something like that? You know, when I was looking at, the different ECMP parts that you were hitting, suddenly you've got some very complex paths getting laid out. As an engineer, how do you know, what are the tools to troubleshoot that?
Yeah, so basically you have the same, this is an MPLS network. Mm-hmm. So inherently, the troubleshooting of a segment routing MPLS network is the troubleshooting of the simplified troubleshooting of an MPLS network without LDP. Okay. But the data plane is all MPLS. So the way how you discover ECMPs, the way how you troubleshoot your MPLS LSP with ECMP is the same. For segment routing in particular, because we have the prefix seeds, there were extensions to MPLS OAM to be able to ping and trace segment routing FECs.
Okay.
So you have the extensions to MPLS OAM for segment routing. We have very neat solutions and innovations that we are going to be shipping this year where with segment routing, I'm able to detect black holes in my network. Let's say, Kevin, actually, if I use the picture, I want to be able to verify that as a router in a given plane, I'm able to forward traffic to any destination in the Flex Algo or in the general topology without dropping any traffic. And I don't want to be able to run BFD on every LSP. I'm running a localized function that allows me to test my own data plane. And we use segment routing principles to trick the network, where Kevin will produce a packet that will go to his neighbor will send it back to him because it has a label stack. And with that, Kevin has created a packet that will become data plane for him. You send it to your upstream, the upstream will say, I gotta follow the label. The label says, comes back down. Now you forward, you have no clue. The packet is coming back to you, and now it goes to him. The packet has a TTL that will expire. When it gets to him, he will say, sorry, I couldn't forward. Then you say, got it, it works. We call that segment routing data plane monitoring. If you go to segmentrouting.net, there are demonstrations for segment routing DPM.
So in regards to, obviously you're using telemetry and all that to be able to calculate this. But the tool, the UI that you were showing, is that where, so for example, if, back to Kevin's point, how do you troubleshoot this, right? Because it's always changing. That telemetry data, is it coming back to that UI? So for example, if you call me and tell me that something happened.
Yes.
I have historical data, right? So I can go back and track.
Actually, actually, this is just a sample UI. Cisco is going to be releasing a segment routing traffic engineering user interface by the summer of this year. So we'll talk more about that when it comes. But in this particular prototype, we are using the knowledge from the ISIS topology to express and display what the topologies look like, to express what the policies look like. If there are other fits like telemetry or performance, these are add-ons into the whole package of how you troubleshoot.
Okay.
Are there any differences in functionality between ISIS and OSPF as far as what you can do in segment routing? Are they functionally fairly identical?
Oh, this is so important. I don't know how you came up with that question, because I gotta tell you, you have vendors who forget about OSPF. You go in and you say, I want to do segment routing. You want to do ISIS? No, I want to do OSPF. Sorry, come back. The answer is no. There should be no difference between ISIS and OSPF. They're equally capable. For Cisco and our prioritization, we need ISIS and OSPF to be at par. Why do we do that? There are many customers. Remember bringing SR to the masses, TE to the masses? Many customers run OSPF. It could be a financial company. It could be a health company, a big enterprise. It could be a service provider in South America. Service provider in Japan are most likely running OSPF. Service providers in Europe and some service providers in the US are ISIS shops. But there are no difference between ISIS and OSPF. If you go back to the draft slide, the IETF draft, that draft covers both ISIS and OSPF, so no difference whatsoever. There should be no difference. If there is a difference, it will be an artificial difference created by the vendor and their ability to deliver the whole story, which is not our case, or their inability to deliver.
I'm going to claim ignorance. Where does BGP?
Well, BGP here actually came on being able to provide me the service routes with the intent, in this case, the caller, that ultimately allowed me to go into my FlexAlgo topology.
Okay.
So what have we done? We have talked about FlexAlgo. What is FlexAlgo? Is the new member of the Cisco SRTE toolkit. The benefits now allow the carrier to define what the FlexAlgo will do. The benefits depending on what type of platform you have, is that you are enforcing a traffic engineer path with a single label. And that opens the door for a lot. Because FlexAlgo is a member of the SRT family, it leverages all the things that Cisco has been doing with segment routing for the last 5 years. It leverages automated protection, TI-LFA. It leverages automated steering. It leverages on-demand next hop, which allows me to create policies on demand. So we're not creating a Frankenstein that, oh, sorry, if you do FlexAlgo, then you lose all of that. It's all an integrated family of solutions. It's real, it's shipping. You are more than welcome to try it out. If you ever want to get your hands on it and be able to better understand, feel free to contact us in case you may not have access to some of the images.